Welcome to day 28 of Math 111. In this lesson, we will be talking about the addition and subtraction of fractions. When we think about addition of fractions that have common denominators, we can model these easily with fraction circles, fraction strips, number lines, and things of this nature. It is easy to see that when we add two fractions with the same denominator, that the numerators are added. Look at the number line model at the bottom of the screen. We can see that the number line has been divided into eighths. We're adding 3/8 and 2/8. Notice how the hops are made here. And the sum is 5/8. Our rule for adding fractions when the denominators are the same is A divided by B plus C divided by B is equal to A plus C divided by B. Notice that the denominator stays the same, but the numerators are added. When our denominators are different, we have a little bit of a different challenge. Adding fractions with unlike denominators makes sense. Think about this. Suppose you order two pizzas of the same size. After everyone is eaten, 1/4 of one pizza is left and 1/3 of the other is left. It may be your practice to put all of the leftovers in the same box. You're adding 1/4 and 1/3 in that case. It makes sense. Well, what exactly do you have after you've added that? When we rewrite the fractions to have a common denominator, then our addition operation is much easier. Any common denominator will work, so we can think of finding common multiples of the denominators. When we use the least common multiple of the denominators, we have a more efficient case. And frequently, the resulting fraction does not need to be simplified any further. Let's look at the example we have at the bottom. We're adding 5/6 and 1/4. A common denominator would be 24, but that's not the least common multiple of 6 and 4. The least common multiple of 6 and 4 is 12. So we need to think about what do we multiply each of these denominators by to get 12. Starting with our first fraction, 5/6. We can multiply the 6 by 2 to get 12, so we need to multiply the numerator and denominator both by 2. We're multiplying by 1 here, so the fraction's value stays the same. You'll notice that we're multiplying 5 by 2, we're multiplying 6 by 2, and that will give us 10/12. The second fraction is 1/4. What do we multiply 4 by to get 12? We multiply by 3, so we will multiply both the numerator and denominator by 3. Again, we're multiplying 1/4 by the equivalent of 1. Its value stays the same, but we're changing this so that we have a new denominator, which is 12. So 1/4 is equivalent to 3/12. Now that our fractions have the same denominator, we can add the numerators. 10/12 plus 3/12 is equal to 13/12. Subtraction of fractions also requires a common denominator. We will not look at an example of subtraction right now. The process is the same. Let's think about mixed numbers for a minute or two. I'm sure you have seen mixed numbers before. This is where you have a whole number and a fraction. Things like 2 1/2, 3 7/10, and 1 5/8. It's important for our students to realize that this is actually addition. We frequently use juxtaposition to denote multiplication. So this is not 2 times 1/2 or 3 times 7/10. The addition sign has actually been suppressed in these expressions. Think about how you read it. 2 1/2. We say and, which implies that we've got addition. When working with mixed numbers, we frequently need to convert them to standard form of a fraction. I've shown at the bottom two different methods for converting to standard form. On the left, we have a method that's a little bit less conventional than what we normally use. The method on the left uses the idea of getting a common denominator. So we write 2 1/2 as 2 plus 1/2, and then get a common denominator, which is 2. The whole number 2 can be expressed as 2 over 1. And so when you look at your denominators, which are 1 and 2, the least common multiple of 1 and 2 is 2. So we go about finding the common denominator. So we convert 2 over 1 to 4 halves. 1/2 doesn't need to be changed. So we add 4 halves and 1/2 to give us 5 halves. The method on the right is a little more common. This is the method you probably use whenever you convert a mixed number into a fraction. We multiply the whole number by the denominator and then add the numerator. So you'll notice that I multiply 2 by 2 and then add 1, and our denominator stays the same. 2 times 2 is 4. We add 1 to give us 5. So 2 1/2 is equivalent to 5 halves. Let's apply that property in our next example. We are subtracting mixed numbers here. 3 4/5 minus 1 1/3. The first thing we're going to do is rewrite each of the mixed numbers as a fraction. So for 3 4/5, I multiply 5 and 3, and then add 4, which is the numerator, and the denominator stays the same. For 1 1/3, I do the same thing. 3 times 1, that's the denominator times the whole number, plus the numerator, so I'm adding 1. When I perform these operations, I get 19/5 and 4/3, and I'm subtracting. I need to get a common denominator now. The least common multiple of 5 and 3 is 15. I need to multiply both fractions by numbers so that my denominators will now reach 15. The first fraction can be multiplied by 3 over 3. So 19 times 3 is 57. 5 times 3 is 15. The second fraction, 4/3, can be multiplied by 5 over 5. This gives us 20 over 15. Now that the denominators are equivalent, I can simply subtract the numerators. 57/15 minus 20/15 equals 37/15. Make sure that you can comfortably perform these types of operations. As we finish this lesson, I want to make sure that you have some vocabulary that you understand. A proper fraction is a rational number of the form a over b, where the absolute value of a is greater than or equal to 0 and less than b. In other words, the value of the fraction is between -1 and +1. In more common terms, we would say that the numerator is less than the denominator. Be careful, though, whenever you think about negative fractions. Examples of proper fractions include 5/13, -6/7, and 0/3. Notice how the numerator compares with the denominator. An improper fraction is a rational number which is not proper. So when you convert a mixed number to a fraction, you will get an improper fraction. Think about the first example we did, 2 1/2. 2 1/2 is equivalent to 5 halves. This is an improper fraction. So we have some other examples of improper fractions here. 15/13. Notice how the numerator is greater than the denominator. 50/50 is equivalent to 1. This is actually an improper fraction as well. A unit fraction has the form 1 over b, where b is not equal to 0. We recognize unit fractions because the numerator is 1. So notice these examples: 1/3, 1/7, and 1/10. The ideas in this lesson are very, very important. Being able to efficiently and comfortably add and subtract fractions is very important for the students in the future as they go through their educational experience. Make sure that you are comfortable with these ideas as well.